Hi, this is Synthchaser from Synthchaser.com, and we're here with another ARP Pro DGX, yes, another one, and I promise this video won't be as in-depth and boring as some of my other videos on repairing and restoring the ARP Pro DGX and Pro Soloist. This video is for John. John's building a collection of ARP synthesizers, and he's getting a pair of matching Pro DGX and ARP Omni 2 from me. So I thought it would be cool to show him his keyboard before the restoration work and after the restoration work. Unlike most synthesizers that I pick up and restore and resell, this one actually came to me working. Well, I mean, it wasn't working, but there was a connector unplugged. But I mean, there's some issues here with the keyboard. But I mean, the aftertouch is even working. Hear the volume get louder as I press harder. It may be working, not 100%, but it's working. But nonetheless, we're still going to give this a complete overhaul. We're going to repair this broken switch. We're going to replace it with another switch. Going to replace the sliders with orange LED sliders, and the Omni 2 that he gets is also going to have the matching orange sliders, which looks really cool with the orange and black color scheme of the keyboard. There's a chipped key here, and then these other keys are either dirty or have paint or something on them. So we're going to get those cleaned up, and that's for cosmetics. Let's open it up and I'll show you what I'm going to do inside. Looks like there's only one screw holding this closed right now. And so this is inside, and I will move the camera up a little bit so you can see a little bit better. Inside it's all original, so this is the original power supply with its original capacitors. All the little blue blobs here are short circuits waiting to happen and destroy valuable chips and transistors in this keyboard. So we're going to replace all these, so we're going to recap the entire keyboard and replace all those failure-prone tantalum capacitors. We're going to make sure everything is working. We're going to rebuild the keyboard. We're going to replace the touch sensor. I mean, it sounded like it was working, but if the original touch sensor is still working, it's not working as well as a replacement one would be, and it's probably not going to be working for very long. So basically we're going to do a full overhaul internally of this keyboard, and then some cosmetic changes like the switch, cleaning up the keys, and the LED sliders. So I will get started on that and check back in with you and show you my progress. Here's the power supply pulled out. I've already cleaned off all the old thermal paste junk that was on that heatsink. It was really dried up and crusty, really not doing any good, and it was loaded with dirt. So we're going to put new heatsink compound down there when we put it back in. But then what I'm going to do now is I'm going to take off these old tantalum capacitors and this dented up electrolytic capacitor and the other electrolytic capacitors as well. And we're going to rebuild the power supply and get it ready to go back in. And here's the power supply rebuilt with new capacitors, here, and here. And it's ready to go back in. There's the old ones. The new ones, even though they're about the same size, they're actually rated much higher voltage rating, which means that they'll last longer because we're not using them at that high of a voltage. And also, these main filter capacitors are higher temperature. They're 105 degree rated capacitors, which again means they're going to last a lot longer than the old one, which was rated 80 degrees Celsius. And these are so old that they don't even have the rating on them. Another thing that I did was I took a look at this connector, the power connector, and I looked in here at the actual connectors to make sure there was no corrosion on them, and that they looked okay. And if they were shiny and clean still, and if they had junk on them, then I would have replaced the connectors on this cable. But everything seems to look okay. The power supply is rebuilt and ready to go back in. For most synthesizers, a power supply rebuild would be sufficient preventative maintenance, but with an ARP, you really need to recap the whole thing. These little blue blobs are little ticking time bombs waiting to short circuit. So we're going to go in and we're going to replace all the remaining polarized capacitors, the tantalums and any aluminum electrolytics, which I think we just got them all. But we're going to go and replace those now as a preventative maintenance to keep this running reliably for years to come. So here are the guts of the Pro DGX. This is the board that lets you select which voice you're doing. This is the slider board, which also has it's the waveform generator or oscillators on there. This is the board with the filters. There's some fixed filters, high pass, low pass filters, and resonators. And there's also this module here, which is the voltage controlled filter. This is the 4075 voltage controlled filter. It's the same VCF that's found in later Odysseys. It's in the ARP Omni, in the Quadra, the Avatar. And we're going to take this submodule out and we're going to make a modification to it, which is going to correct the cutoff frequency of this and make this filter work a whole lot better. This is the envelope generator that has the ADSR. And this board here does the touch sensor effects, or many of the touch sensor effects. Some of them are off on other boards. There's a few capacitors that we're not going to change. Specifically, this one tucked here under this switch. It's very difficult to get to, and unless there's a reason to change it, you're going to wind up doing more harm than good changing it. There's also a circuit board under the keyboard that the key contacts are soldered onto, and that one is not worth changing unless you have a reason to do it. It's again, one of those things that you can mess things up a lot more easily than in other areas of the synthesizer. So I tend to leave that capacitor in place unless there's a reason to change it. So I'm going to go recap these areas of the board, and I'll let you know if I see anything interesting. So when you have the boards out to recap them, it's an excellent opportunity to look over everything and make sure that there's no other problems or no prior work that needs to be reviewed. I did notice a couple of capacitors had already been replaced here. Looks like there's a broken trace with a resistor soldered across here, so I'm going to go and confirm that that resistor does in fact belong there. And there's a trimmer missing here and kind of a ugly hack of a trimmer soldered on the back. So I'm going to take a look and make sure that that's connected okay. This is probably actually a better quality trimmer than the trimmer that's there. So if it's the same value and it's connected correctly, I'm going to leave it. But I am going to look it over and make sure that it's okay. As ugly as it looks, it may actually stay here. Another thing that I did while I had this board out, this is the filter board, is I removed the voltage controlled filter module. This is a 4075 filter submodule, and I recapped it and performed an enhancement on it that greatly improves the cutoff frequency response for the filter. So that's going to make the instrument sound a lot better. After recapping, but before moving on to the key bed, one other thing that I had to do was to replace this switch. This switch was broken there and looks really ugly. So I found another Pro DGX that I had. Unfortunately, it's not one of the ones that you can just fold open. It was the kind that you have to open from the bottom and take all the guts out. But what I did is I took out one of the white switches, and then I replaced all the internals of it, the contacts and this bottom board here, with a new one from a black switch, which I have replacements for and I sell on my website. But I don't have any replacements for the white switches, so I had to find a donor, and then I replaced the internals. So essentially it has the original white appearance, but inside it's like a new switch. And then this is the stuff that came out of the inside. I think I already threw away the electrolytic capacitors from the power supply, but the old sliders are pretty dirty, and a bunch of the tantalum capacitors came out as well. I've got the keys soaking in warm soapy water, and I'm not sure that that's going to be good enough actually to get them clean, so we might have to do some more aggressive methods on them. So I've removed all the keycaps. You remove these screws and then take the keycaps off, and that's what's soaking in water, the white and black keycaps. And then you remove the springs from the back here, and then you can pull off these little key levers. And underneath I see that the bushings are all white and hard and brittle, so I'm going to be removing those and replacing the bushings on all the keys. I'm going to turn it over and I'm going to clean the bus bar and the key contacts. I'm going to adjust everything and put it back together. And the Pro Soloist Pro DGX has a touch sensor, has aftertouch, and this is the touch sensor bar. Basically when you press a key down hard, forgive me, it's disconnected here, but it presses down on this felt and sends a signal up through this wire of the board to engage the aftertouch. These sensors, this one was working, it seemed to be working, but if it's not been replaced, if it's working, it's probably not going to work for very long, or it doesn't work as well as a new one. So I'm going to be rebuilding this touch sensor by removing the felt and replacing the touch sensor and putting the felt back down. I also sell replacement touch sensor assemblies where you don't have to do any of that yourself on my website, synthchaser.com. Interestingly enough, only these 3 bushings were old and brittle. The others look like they had been replaced, but I'm still changing them. It looks like whoever lubricated them used mayonnaise or something like that on it, and then some of them they didn't even lubricate at all. So we're going to replace all the bushings with new ones, properly lubricated, and it'll be a nice consistent feel across the keyboard. And here's the new bushings installed, so they're nice and uniform all the way across. And disassembling the keyboard in this manner also gives us the opportunity to adjust the key stops. Oftentimes on old synthesizers or vintage synthesizers, you have keys that are higher than the other keys, and that's caused by these becoming not level. So push too hard and it gets bent down a little bit. Oftentimes over the years the keys in the middle of the keyboard tend to sag a little bit because they've been pushed on so much. So with the bushings off, it gives an opportunity to make those level, so the keys, when they're reinstalled, will be nice and uniform and level across the key bed. So the keys are done taking their bath, and as I feared, some of the stuff, it appears to be stained. So these keys don't look acceptable to me, and it's quite a number of keys that are affected by this. They're not scratched. Only one of them is chipped. That one I'll replace, but I'm going to see if I can get this white and shiny. So with the wet sanding process, I start with a 600 grit, and I go up to 3000 grit, and then I use a Novus plastic polish, and I turn the keys from this into this. It seemed like it took forever, but I finally got the key bed back together. What took the longest was the keys. They were stained, and I had to sand them and polish them, and it just took a lot of time. And I did it to all the white keys so they'd all look consistent. And some of them were so stained I needed to start with like a 320 grit, and then I moved up to 400, 600, 800. 1000, 1200, 1500, 2000, 3000, and then I used a plastic polish from a company called Novus, and the result is the keys are very shiny, and they look like new. So I've got the key bed reassembled, I've cleaned the bus bar, put on the new bushings, reinstalled the rebuilt aftertouch sensor, the touch sensor bar. And this is almost ready to go back into the keyboard along with all the other electronics that we've recapped and improved. But before I put all that stuff in, I have to fabricate a new panel for the bottom. So the Pro DGX has a little access panel here. Normally this is covered with a little plastic sheet that screws in here and here and here and here, and it allows you to get to the bottom of the key contacts to make adjustments to them if necessary. And even though you won't see this when the keyboard's reassembled, we don't want there to be openings in the keyboard case. So what I'm going to do is just with a little piece of wood, I'm going to fabricate a new little panel to go over here. It doesn't matter what it looks like since you won't see it. Normally we just want it to be closed so dust and other stuff doesn't get in, such as in my last video, Synthchaser 39, where mouse had gone inside an OBX and peed all over the circuit board. So we definitely want to prevent stuff from getting in. So we're going to make a little panel to cover this up, and then we're going to put everything back together and test it out. So with everything back together, I was taking a look at the keys, and everything's nice and quiet with the exception of this key, which makes a little bit of a clicking noise. And I noticed something that I didn't notice when I was refurbishing the keys and sanding them and washing them and everything, was that there's a tiny crack here. Let me make sure you can see this. This little piece is missing in the middle. So I've gone and I've taken a replacement D key and I've sanded it down. You can see that this one does have there's a little groove here, but not a big chunk missing. So I did the same sanding process to this other replacement key that I did to the first key, and I'm going to put it in here, and that should quiet that down. Because I mean, we're changing the bushing so everything is nice and smooth and quiet. We don't want any weird noises that shouldn't be there. There'll be some noise that you hear when the keys, the little wire clicks against the bus bar. So there's some noise, but now you can hear that clacking key is fixed. So everything's back together, and you know, everything still works. We did the filter enhancement, so here's. We replaced the touch sensor, so it's I have touch sensitivity turned up all the way, but the touch sensor before, it was kind of intermittent throughout the keyboard. Even though it worked, it didn't work really reliably. So now it's going to work reliably across the whole keyboard. It's going to be nice and sensitive, and you won't have to really force it to get the touch sensor effects. And you can turn it down so it's not as pronounced. But we still need to calibrate this. So right now it's not been tuned, the filter hasn't been calibrated, touch sensitivity hasn't been calibrated. There's not a whole lot of calibrations to do on the Pro Soloist or Pro DGX, but right now it's not in tune, and you can hear as we go down. Well, you can hear that it actually kind of goes higher in pitch when we get to when we switch between octaves, and that's because this doesn't use a traditional volts per octave oscillator. It uses something called a waveform generator, is what they call it, and it's basically when you press a key, it sends a digital code with note and octave. And your oscillator really only tracks across one octave. So in this case, the volts per octave is not set correctly, and that's one thing that we're going to calibrate. So I will open it up and we'll get it tuned. I'm actually going to go ahead and break out the calibration procedure into a separate video. If you click the link, you can get to that. This way, people who aren't interested in the boring details of calibrating your Pro Soloist or Pro DGX can skip that part, and people who are just looking for that information can skip the rest of the restoration stuff. So you can click the link for that video, and then we'll continue to wrap up this restoration. So I completed the calibration of this Pro DGX, and while I was doing that, I found that I had a hard time getting it to tune correctly across the octave. And if you watch that video, you'll see that I made another repair to the keyboard, replacing a bad TTL chip in the digital to analog conversion section. So now it tunes, it's tuned, it's calibrated, everything on it's working. I found the knob was inside the case, and it's ready to go. So if you have any questions, please post in the comments or contact me through my website, synthchaser.com. Hope you enjoyed this video. Thanks for watching.